So, by the way, no, there's a survey already for return to class in Daegler. Have you seen it?
Yes,
I don't
sir.
think it will happen this year, no. And for me, I'd like that they finish the semester first, rather than convert to classes within the middle of the semester. Kasi ang gulo-gulo niyan. Nagsimula, di ba? And I don't think it can be done, no, because it's the positivity rate is still very high. Is there Almirol? Si Ang nandito ba? Nandyan. Atian Sar. Bation. Wala si Bation. Dabon is here. Si How, wala na si How. Hardinel, what happened to How? Villar Loares not yet here. Okay. So anyway, we will have our second formative test by October, no? Middle to the last week, no? Maybe third to the last week of October.
Ay, sir.
Yes. Yes.
My exercises, sir, graded po, sir.
Hindi.
Or assignments.
Wala yan. They're just used for formative assessment. Okay? What happened to how about in your other classes? How are you graded? Di ba summative lang? Summative assessment lang? It's in the online.
Formative, sir.
Wala ay nasa OIDP. Summative lang. It's in the OIDP policy.
Sige po, sir.
Maybe I'll just ask, no. I'll just our chairman again. Maybe I was not. There's an update, no. If there's an update, okay, we'll find out, no. If it will help you increase your grade. Okay. Kasi
So far, sige po, sir. So
How
far,
about-
sir, 100% ang summative assessment, sir.
yes. How about the last semester? How did your teachers gave your grades?
Mix of formative assessment and summative assessment po, sir.
Okay, I'll try to consult that, okay?
Sige po, sir.
Kasi wala man ako na-receive na email regarding an update on the OIDP policy. Basta formative assessments are just a requirement for you to take the summative assessment, which means you cannot take the summative assessment if you cannot pass all the formative assessments. Okay, you follow?
Yes,
Sir,
sir.
speaking, sir, kanusa ito mag-summative?
At the end of the semester,
Sige.
once lang
Bali,
Bali
mong plan nun ta, sir, kay isa lang ka summative assessment tapos nakabase na dito among grade, sir.
Yes.
I
Is
didn't
there
know
an
pwede
update of the new OIDP? Mayroon bang bagong update? Because I've been doing that ever since we started, Wala pa akong na-receive na update. I didn't receive the email. And if it's going to be updated, it's going to be discussed in a meeting. Anyway, I'll try to check myself, To look at the questions of, by the way, look at the questions of the survey to return to campus. Have you seen this yourself?
Yes, sir.
Is there a need to return to campus? Is there a need? Traffic. I don't think there's a need. If I were to return to campus, I would still have the online option, which means if I'm going to hold class in the classroom, I'd still do it this way, so that others who are from far places, far away, can participate online. Ganun pa rin. And then I will still record my sessions so that the students can review the sessions. Diba? We have practiced, we have done, sayang naman kasi yung okay? Yung na-build, the resources that we built. We have built a lot of, like the materials, the online quizzes, ang dami nang na-build, So anyway, you will have another assignment. This is pure K mapping, I have already the solution on 5.3. This is 5.3 to 5.7. Okay? Matagal naman ito. There are too many, but simple lang, Okay? And there's already a second formative assessment coverage, which will cover only Boolean algebra, Boolean expressions, truth tables, deriving SOP and POS forms, minterms and max terms, Boolean simplifications, De Morgan's theorem, basic laws, and consensus theorem, by the way. And then we have Boolean algebra and K mapping. Okay. And then we'll discuss comparators, encoders, decoders. Okay, do you follow? And you are supposed to do fourth experiment. No? What is our fourth experiment? Consider logic lang lahat, no? I haven't seen this anymore, no? Experiment 4. So you pass this on a zip file, no? Because the Cedar logic file cannot be did you pass your Cedar logic file in the assignment? Okay ba? Because the first time I passed it, no? May problema ako doon, no? Hindi tayo mag-open. Okay, sandali lang, no? Okay. So anyway, for the moment, we will proceed with our next topic. And then we'll have experiment 4. No? Individual ito. Okay. We have this. Okay. Okay. Experiment 4 encoders. Okay. So kaya itong experiment 4. Can you do experiment 4 this week? No? Encoders. The individual na lang ito, no? In Cedar logic. We will discuss the different logic circuits today, no? Do I have the Wala. I will upload the PowerPoint later, no? Okay. But anyway, it's still in the it's still in the on the same file that we have, no? On constructing logic circuits. Okay. Diba? Ito, no? Okay, do you follow? Do you follow? Let's look at the common logic circuits. The binary decoder. This your next experiment is this, no? Yung binary encoder. Ito. Do you follow? I'll have a sample on this anyway, no? But you will test. There are answers that you need to answer in the test, no? And then enable switch multiplexers. The multiplexers we have word comparators. Wala tayong word comparators, no? But we'll discuss that today, no? Any questions? First is a basic binary decoder. What is a decoder? You know, our code is in binary, right? When we decode it into something more comprehensible. We do not decode it into English, no? We will decode it into decimal. On the other hand, no, on every binary device, electronic binary device, like cell phones, no, calculators, computers, no, the output is displayed in decimal, right? When you look at Excel, no, Excel will display the result in decimal, although inside it, no, the numbers are computed using binary by the machine. Okay, so there's a need to convert somewhere in the circuit, no, the binary numbers, the results in binary into decimal. That's called a decoder. Do you follow? How do you convert a binary decoder? How do you convert a binary into decimal using a logic gate? The very useful gate is the AND gate. No? Pag decoder, the other circuit is encoder, no? So pag decoder, the gate that is used is an AND gate. For example, if you will have if you'd like to decode the value 1011, this number is what? 11. Okay? You'll need to use an AND gate which has 1011 also. Now to signify a 1, you make a straight connection. To signify a 0, you make an inverter. Do you follow? So this signifies 1011. Okay, this is able to decode only one value. Do you follow? This is able to decode only one value, which is decoder in which decodes the value 11. Okay, do you follow? Later we will talk about an encoder also. Now let's try to construct this decoder in Cedar Logic so that we will know. Okay, so let's say we will convert a 3-bit decoder, no? A 3-bit decoder. So if you have a 3-bit decoder, okay, you'll have 3-bit inputs, and you will have 7 different outputs. Okay, we will construct that, no? And by the way, no, this is the circuit of a 3-bit. This is the truth table of a 3-bit decoder. If you have 0, 0, 0, you have 7 outputs, 0 to 7. Only one of which is high, depending on the decimal value. For example, for 0, 0, 0, you will have this as D0 as high. No? If you have 1, 0, 0, 1, it's D1 that's high. If 0, 1, 0, D2 that's high. No? And for example, 1, 1, 1, it's D7 that's high. So Villar Loares. Okay. Okay, so let's construct this in let's construct this in Cedar Logic. Close ko muna, no? I've already constructed the circuit, but I'll construct it again. Okay, ito, 3-bit decoder. So if you look at our PowerPoint slide, it's like this. Ayan. Do you follow? Let's find out how it's constructed and how it works. Okay, anyway, we don't need the notes. It's easy to construct, no? Basta we have 3 inputs and 8 outputs. Okay, this is our A0. So a decoder is a logic circuit, no? Maybe this 8, 8, 2. Okay, and we will have 7 outputs. Medyo matagal ito, no? But the other circuits I have already drawn myself, no? I'm just trying to show you how this is done, no? But, the other circuits I'm just going to show you them directly, no? We're not going to build them one by one. Pwede ba ito i-copy? Hindi pwede mag-copy, no? Kasi kung mag-right click ka, mag-ano siya. Okay, so we really have to do this one by one. Okay. And then there's our ano. Have I recorded this already? Baka nagkamali na naman ako, no? Yes. Okay. You follow? So this is our output and this is our input. So in our input, we will need an input gate. Now we have a problem here because if you look at our connection, okay, if you look at the PowerPoint connection, there can be at most 8 connections per point. Okay, like for this A2, ang dami. This can be at most 8 connections per point, but our connector can only give us 3 connections. There are four sides, right? But we will connect the output. Since we will connect the output to the, or rather connect one of them to the input, so we are left with 3 vacant connectors. How do we make 8 connectors? We will make a combination of 4 connectors. Okay, one of which is the central, is like the central distribution point, and the other is connected to that central distribution point. For example, how can we make 9 available connections to A0? So we'll just make use of this like this. We'll move it here a little para medyo magkano. Okay, medyo malayo. Because anyway, we have a widely spread output. Pwede natin layuin. Okay. Like this, no? Do you follow? So we are trying to do this because we lack connectors, and then we connect this to that. Okay. So which gives us 9 additional connecting points. 1, 2, 3, 3, 6, 9. No? And if you need 8, so we can make use of this. Otherwise, you need another one. Okay. But this at most, the 3 connectors can at most give you 9 connecting points. Okay. Layo natin konti para hindi magdikit-dikit. Because the problem is if your connectors are too near each other, your circuit can easily, no? Mahirap siya i-trace. Okay? Kung nagkadikit-dikit sila. So we'll do that here also. So magkalayo yung connectors, mas okay. Okay. So for D0, how do we configure D0? We will need an AND gate. It's AND gate. For an input of 0, we put an inverter. Okay? That's basically how it's done. For an input of 0, we put an inverter. For example, we have this connected to D0. Okay? Since D0 is 0, 0, 0, we will need 3 inverters. Okay? 3 inverters. Sorry, this is a large inverter. We need a small inverter. Move natin to sa taas. We run out of space na. Do you follow? Okay, and then the first inverter we connect to A0. The second inverter we connect to A1. See, it's better that we have a widespread. And then the third we connect to A. We just arrange. So maganda i-arrange natin ng konti. Hindi sila magdikit-dikit. Okay, from the start. Do you follow? Okay. Now, for 1, we will have 0, 0, 1, right? So we'll have 1, 0, 0, 1. So we'll need 2 NOT gates because there are 2 zeros in 1. Okay. 0, 0. Okay. So this one we will connect to A0. Okay. This one we will connect to A1. And this one we will connect to A2. Okay. So it's cleaner now. No? And then we'll connect this to D1. You follow? Okay. You follow? So if you'll have 1 here, for example, so we'll have D1. If this is a 0, so we'll have D0. You follow? Wala pa tayong 2, no? Wala pa tayong, di pa natin na-connect ang 2. Now to make a 2, we'll need 0, 1, 0. So we'll need only one NOT gate. Two NOT gates. 0 NOT. Okay. Sorry, no. 2 inverters. Here. We connect this to A0. Then we connect this to A1. Then we'll connect this to A2. Okay. Then we connect this to D2. Okay, so let's try to click 2. 2 siya. Wala pa tayong 3. But if we have a 1 and we have a 0, do you follow? So we are now converting binary to decimal. That's what we're doing. Do you follow? So now we convert D3. What's D3? 0, 1, 1. Right? So kung 0, 1, 1, we only need one NOT gate. It's here, no? Dito natin kailangan. 0. Okay, and this one will connect to A0. Gulo-gulo na, no? And then this one will connect to A1. This one will connect to A2. Okay, if you follow on this one, will connect to D3. Okay, so we know what 0, 1, 2, 3. Let's try 1. That's 1. Let's try 2. That's 2. Let's try 3. So, okay, so we are now able to convert the first 3. Now we'll have 4. How do we convert 4? 4 is 1, 0, 0, right? So we need 2 NOT gates. Okay, 4 is 1, 0, 0. So we need 2 NOT gates. The first and the second. Connect pala siya kagad, no? Ganyan mo lang, oh. Oh. Okay. It's nice. 1, 0, 0. So we'll connect this to A0. That's all right now. It's in place. We'll connect this to A1. And then we'll connect this to A2. Okay, okay lang ito. This is okay. This is because it's connected to both like that. So it's okay, no? It's legible. And then we'll connect this to D4. Save this. Okay, let's try 4. What is 4? 1, 0, 0. 1, 0, 0. That's 4. Okay, we don't have a 5 yet. Pero meron na tayong 3 and 2 and we have a 1 and we have a 0. Do you follow? So it converts. Questions? Yes.
Nasa waiting room po si Patrick.
Si Patrick, si Hardinel, I'm sorry. No?
Salamat po, sir.
We'll have Hardinel. Anong nangyari kay How? Is How still enrolled? So, itog lang to. Okay. So, D5. What's 5? 1, 0, 1. So, therefore, we need only one gate, a 1 NOT gate. For NOT gate, we need a 0. For a 0, we need here. Shut na. So we connect this to A0. Range a little bit. We connect this to A1. Range is a little bit. And we connect this to A2. Okay. We follow and we connect this to B5. Okay. They follow. Let's try 5. 5 is 1, 0, 1. So that's 5. That's 4. 1, 0, 1. Okay. Okay. Dapat i-move natin ito. So meron tayong 6. Now we convert 6. What is 6? 1, 1, 0. Right? 110. So therefore, we need one NOT gate. Let's connect it. We connect this to A0. We'll connect this to A1. Then we'll connect this to A2. Okay. Do you follow? So we'll try if we have 6. What is 6? 110. Wala pa pala natin na connect, no? We already have 6, 110. Do we have 5? 101. Yes, we have 5. Do we have 4? 100. Yes. So our last value is D7. This is just 111. So we don't need a another gate, another NOT gate, no? 1 1 1. Do you follow? So let's try 7. 7 is 1 1 0. That's 7. That's 6. That's 4. That's 5. Okay. This is 3. This is 3. This is 2. This is 0. This is 1. Do you follow? Okay. I'm going to upload a circuit, Sidor logic circuit, which has everything. Okay. Anyway, I'll close this without saving. I have this already. No?
Yes, sir.
Question?
Sorry.
This should be worksheets and circuits. Okay, so there it is, the basic logic circuits. So this is the page 1 is the decoder, no? Do you follow? Page 2 is the encoder. Okay, let's erase this now. So let's explain what an encoder is. Next is an encoder. An encoder converts into binary. Do you follow? Encode niya. So it usually it's decimal to binary. Do you follow? Now, this is useful on the input side of any device. No? Ang decoder sa output side bago niya i-display. No? The encoders on the input side before it's being entered into the system. Why is that? Because usually, if on the input side, you will have a keyboard, right? You will have a keyboard. And the keyboard is in decimal. Okay? But later, you are going to convert it into binary. So this is the encoding. If the value entered is 0, the binary value is 000. If 1, 1001. No? Do you follow? So this is an 8-bit decoder, 0 to 9, which converts a keyboard, no? The input of a keyboard from a calculator into binary. Okay? So this is easy to configure, no? Because you just look it out from the truth table. Yung truth table nito. So for example, if you have 0, no, the truth table of 0 is 8 and 9. No, A3. A3 is 8 and 9. A2 is 4 and 5. Do you follow? You look this up from the truth table. Do you follow? So that's why we have this. So madali lang naman ito eh. For A0, there's nothing, no? So A0 is not connected. When can you have a 1? Okay. when can you have a 1? You can have a 1 if you have 1, 3, 5, 7. Okay? So we have 1, 3, 5, 7, and 9. Now, why is this? Now, we only have a 4 input OR gate. We need a 5 input OR gate. 1, 2, 3, 4, 5. So we can do that by utilizing a 1 extra OR gate. A series of ORs is just 1 OR. No? They follow? Now, for A1, when can we have this? When we have a 2, okay, and then we have a 3, because 1, 1, 1, no? And then we have a 4. Do we have a 4? Yes. 1, 1, 0, and then we have a 6, no? And so on and so forth. So what happens is, from the truth table here, okay, we create a circuit with 4 outputs. Okay, so let's try this. If you tap a 0, it will be 0, 0, 0. Okay. If you tap a 1, it will be 0, 0, 0, 1. Okay? Imagine this as a keyboard. Okay. If you tap a 2, you will have 0, 0, 1, 0. If you tap a 3, you will have 0, 0, 1, 1. If you tap a 4, you will have 0, 1, 0, 0. Okay. I've been talking for a while now. Wala na akong candy. Sorry for that, no? Do you follow? So it's like a keyboard here. If you tap a 5, for example, you have 1, 0, 1. If you tap a 6, you will have 1, 1, 0. If you tap a 7, you will have 1, 1, 1. If you tap an 8, you will have 1, 0, 0. If you tap a 9, you cannot tap 2 keys at the same time, no? Only 1. You have 1, 0, 0, 1. Do you follow? So any questions so far? So enable switch. What is an enable switch? It's like a faucet or like an if then else in a programming language. If enable is 1, Y receives 0. Okay, you will say if E is 1, Y receives A. Y is equal to A if E is 1. If E is 0, Y is 0. Do you follow? That's called the enable switch. This controls entry to a bus usually, no? That's the main connection. I think we have it here, no? For example, we have, this is A2, A3, no? Do you follow? What happens to Y? It's just 0, but when you say enable, now it receives A. Do you follow? So for example, we have A here, Y remains the same, but when you say enable, Y receives A. Do you follow? This is usually done by using an AND gate to each input. Okay? When anything ANDed with a 0 will become a 0. So when enable is low, all the output will be 0. But when enable is high, the output will depend on the ANDed A. Do you follow? Anything ANDed with 1 is itself. That's why we have this for the enable switch. Okay? Any questions so far? Word comparator? Okay. Word comparator, wala pa tayo na, but I will binary word comparator. We'll try to build that today. No. It will compare two words. Nandun na. It's one of the experiments anyway, no? Meron tayo experiment word comparison. Do you follow? Okay. We can compare 2 bits with using an XNOR gate, no? We'll do that later, no? Anyway. So the next is a multiplexer. Wala pa tayo dito. We'll do this multiplication later. How can we do that here? Multiplexer. Okay. Okay. What I'd like to discuss next, no, wala dito sa slide, no, is called the ALU, Arithmetic Logic Unit. No? before we do that, we will discuss this later, no? Yung half adder later in the next lesson. Half adder is used to do 2-bit addition, di ba? 2-bit addition using binary numbers. What is 0 plus 0? 0 carry 0, right? 1 plus 0. The sum is 0, the sum is 1, carry of 0. Okay, we have 0 plus 1. The sum is 1 with a carry of 0. 1 plus 1. Okay, we have 0, carry 1. Do you follow? Do you follow? It's called a half adder. Why it's called a half adder? Because it only adds 2 bits. We'll discuss this later. No, in the next chapter we will discuss ALUs. I'm sorry. Full adder. I'm sorry. No. Here's a full adder. It adds 3 bits. Usually you will need a previous carry. No. So 0 plus 0 plus 0. 0 is equal to sum carry 0. No. 0 plus 1 plus 0 plus 0. Sum carry, the sum is 1, carry of 0. Okay. 0 plus 1 plus 0. A sum of 0, carry, as a sum of 1, a carry of 0. 1 plus 1, it's a sum of 0, a carry of 1. Do you follow? But what will happen if you have 1 plus 1 plus 1? You'll have a sum of 1 and a carry of 0. So the sum is using 2 XOR gates. No? Do you follow? And the carry is a sum of products. Okay? Do you get my point? Now, we'll discuss this in the next chapter. This is called an arithmetic logic unit. Okay? This adds 2 numbers A and B. Okay? This adds 2 numbers A and B. So, for example, we will add 0 plus 0 muna. Okay. 0 plus 0 is 0. For example, we'll add 5 and 2. So, shall say A is 5. So, for A to be 5, we'll have 1, 0, 1. That's 5, right? So, 5 plus 0 is 5, no? We will make B 2. So, this one will make it 2. So, okay. Do you follow? So, 5 plus 2 is 1, 1, 1, which is 7. And take note that the last carry here is an indicator of positive or negative. Okay? If it's 1, it's positive. If it's 0, it's negative. Do you follow? The last carry, remember? No? Into complement addition. And so, now, how do we make this into a subtraction? Do you follow? Now, we will create an AND. An AND as a subtract signal, such that if subtract is high, it will do a subtraction. If subtract is low, it will do an addition. Like in this case, it does an addition. Now, what subtraction does is the subtrahend is converted into 2's complement. Okay, so we will XOR the b's with subtract. If subtract of is high, all b's are XORed with 1. Okay, so when it's XORed with 1, it becomes 1's complement. If it's XORed with 0, nothing happens. Do you follow? So the XOR gates will convert B into 1's complement. Now, how is the 2's complement done? Okay, remember that, no? We have full adders. What are these boxes? These are full adders, which means that in each of these we have X, Y, and C. No? So we have X, Y, and C. X, Y, and C. Okay? During a 2's complement, the subtract itself is added as the first carry, which completes the 2's complement, because we have the 1's complement plus 1, that's 2's complement. Do you follow? No? Okay. Let's do the subtraction. For example, this is 5 plus 2 is 7. What if we'll do a subtract? Okay. 5 plus 2 is 3. No? 0, 1, 1, and it's positive. Do you follow? Okay. So 5 minus 2 is 3. 5 plus 2 is 7. When we do a subtract, it becomes 3. Do you follow? Now, why don't we do a 2 plus 5 and a 2 minus 7, a 2 minus 5, okay? Okay, this time we'll make A as 2, so we'll have this as this, no? And B as 5, so we'll have this as 1, 0, 1. Do you follow? Okay, so this is A is 2, B is 5. So 5 plus 2 is 7. This is a positive number. Let's do a subtract. Okay, let's do a subtract. 2 minus 5 is 1, 1, 0, and this is a block, which means we have a 2's complement number. Do you follow? This is a negative number. Okay, the answer is this is negative 3 because 1, 1, 0, 1 is negative 3. How do we know that? Remember that 1, 1, 0, 0 is the 1's complement of 3. Diba? We add it a 1, it becomes 1, 1, 0, 1. And this is a negative number because the last carry is a block. Do you follow? No? So meron na tayo ganyan. We will discuss this again. The enable switch. Okay? What is the enable switch? We have discussed this already? Yes, we have discussed that already. No? Okay? Okay. I-save ko muna ito, no? And then I'm going to upload this to our website. Word comparator. Okay, this is our first experiment, right? How do we make a word comparator? I'm sorry, naghang yung ating ano. Sige pala sa tanong. Sorry. I got cut off, no? Are you still there, everyone?
Yes, sir.
Yes, sir.
Got cut off, but I think the recording is still there. The recording is still there. Okay, a word comparator. How do we compare two words? This is our first experiment. Have you passed this already? The first experiment, no? We can make a word comparator by using what did we do? An XNOR gate and add them together. Okay, so we'll compare A with B. No, word comparator. So let's say enable comparator. No, A and B. We'll start with A0. Then we'll have B0. How do we compare A and A, 2 bits? You follow? We'll use an XNOR gate. Okay. Yan, no? You follow? We'll use an XNOR gate. XNOR gate ito. You follow? We don't need any other connection. Okay. Let's try to put an output here. No? Take note, if both A and B are 0, they're equal. So let's put this. Okay, do you follow? No? If A is 0 and B is 1, they're not equal. Do you follow? And if A is 1 and B is 0, they're not equal. If both A and B are 1, they're also equal. They're equal when they're both 1 or both zeros. That's done by the XNOR. Do you follow? This is our first experiment, right? First or second? You've done this already, right? Now we are not just going to do a comparison of a bit, but we will also compare words. So therefore, we'll just expand this further, no? We'll have A of 1. B of 1. And then we'll have an input. Hindi tayo pwede mag-copy paste dito eh. That's the problem with this. Okay. So we'll need an XNOR. Okay. And then we will need a 4 input AND gate. Now this is 2 input, sorry. Okay. They follow. We need a 4 input AND gate. So if each of it is equal, you follow? So we'll just repeat this again. Dali yung isa, no? Dali lang. Ang sana, ang sana. Sana dong. Oh. Ha? Isa pangan. Ila. Ila. Ha? Ko. I'm sorry, no? So let's just finish this quickly. Anyway, it's the same. So this is B2. We need input. We need 2 XNOR gates. And we need we follow. Okay, so if this is 1, they're not equal. If this they're equal, okay, they're not equal, they're equal, they're not equal. Okay, any questions so far? Now the next is a multiplexer. A multiplexer is like a switch. 1240 time again, no? Di ba, you have an FM radio, right? Do you have an FM radio in your phone?
Yes, sir.
What is a multiplexer in the FM radio? Or in a, ang tawag dyan, in a walkie-talkie? There's also a multiplexer there. When you switch channels, no? When you switch channels, the circuit that allows you to switch channels is the multiplexer. Do you follow? The multiplexer is actually a circuit which chooses a set of inputs to be the output. Okay? So magpili ka ng ilang channels para yun yung maging output. Okay? That's called a multiplexer. There's also a digital multiplexer here. For example, it's like an if then else. If the switch is 0, 0, 0, Y equals D0. If the switch is 0, 1, this is S, no? Switch. Switch. A multiplexer is a switch. If the switch is 0, 1, Y receives 1. If the switch is 1, 0, Y receives 2. If the switch is 1, 1, Y receives 3. Do you follow? Okay? Do you follow? So, gagawa tayo ng multiplexer. Okay. Okay, so we have 3 inputs. Four rather. You will have an experiment on this, huh? Okay, and we'll need an OR gate, a 4 input OR gate, an output muna. Kailangan pa natin ng switch. And how many connections we need to the switch? We need 4. Okay, so anyway, gagawa na lang natin ng isa-isa, no? You follow? 1, 2, 3, 4. 1, 2, 3, 4, okay? Need a connection here. And the switch is another input, no? Okay. Then we need a 0, 0, the address 0, 0. The address 0, 0, D0 pala ito, no? Sorry, this is D0. D1. D2. D3. Okay. You follow? And the address 0, 0 is configured by an AND gate. We'll need an OR gate, 4 input OR gate. So a multiplexer is a selector circuit. This is our input. This is our output. Our output will depend on the value of the switch. It's like a case or a switch statement in C#. Do you follow? So the first is an AND gate. We need a 3 input AND gate because the address is 0, 0. 3 input AND gate. Okay, we need a NOT. Long nuts. This is for the address 0, 0. That's why we need two NOT gates. Okay. So where do we get this? If the switch is 0, 0, which means that it's 0 here, it's 0 there, no? Where will we get the value? We'll get it from D0. Do you follow? Which means if the switch is 0, 0, Y is equal to D0. Do you follow? Okay. Wala pa, hindi pa tapos, no? And then if the switch is 2, or rather 1, 0, 1, 0, we'll get the value from D1. Okay? No, 3 lang, 3. Sorry, no? That's what I don't like. Ito mahirap sa mahirap sa Cedar Logic. What's the value here? This is 0, 1, 0, which is 1, no? So we'll need 2. Okay. Sorry. If the switch is 1, no? Sorry. Move na naman siya. Okay. Switch is 1. Mali ako. Okay. What's the value of 1? 0, 1. Mali ito. Dapat S0 ito, no? Klaro. So 0, 1. So the 1 is ito dapat ang 1. Kasi tap natin dito. This is a 0. Ano? Mali. Sorry, no? 0 is the 2. Ayun na mag-connect. And then you mag-connect. So anyway, we'll just connect it ourselves. Okay. So this is a 0. This is a 1. And we'll connect it to a D1. We follow? Okay. And then we'll need a 2. A 2 is a 1, 1. Okay, so we don't need a NOT gate. Okay. Then we need a 3. No, a 2 pala is 0, 1, 0. So we need a NOT gate here. 0, 1, 0. So we need a NOT gate here. Okay, you follow? 1, 0 is a 2. A 3 is the one that where we don't need an AND gate. Okay. We'll connect this to this. This. Do you follow? Do you follow? Shall we say 1, 0, 1, 0? Okay. Now, if the switch is 0, this is 1. This is 0 because it equals to D0, right? Okay. If the switch is 1, This is 1 because it equals to D1. Okay. If the switch is 1, 0, that is 2. This is 0 because it's equal to that. If the switch is 1, 1, this is it because it's equal to this. You see the red colors? Do you follow? So there's a multiplexer circuit. No? It chooses the input depending on the value of a switch. So a multiplexer circuit has two actually sets of inputs, the source and the switch. Okay, like in an FM radio, no, you have a lot of channels, and the multiplexer will allow you to tune the channel which you would like to play. Okay. Any questions so far? So one more tayo, no? One more. DeMux. Ito na naman ang DeMux. Gamit ito eh. This is used in computer architecture. No? So a DeMux is the opposite of a multiplexer. No? A multiplexer uses a source to be the output. No? A demultiplexer uses, okay, chooses the output. Okay, kung saan papunta. Given a source, where do you output? Do you follow? So it's the other way around. Here's the demultiplexer, no? You only have one input, you have 4 outputs. Do you follow? Do you follow? 4 outputs. If it's 0, 0, 0, the output will go to Y0. If it's 0, 1, the output will go to Y1. If it's 1, 0, the output will go to Y2. If it's 1, 1, the output will go to Y3. Do you follow? So I can add it here, no? This is the multiplexer anyway. So we'll add a demultiplexer. The short for multiplexer is a demultiplexer is DeMux. Pag multiplexer naman, the short for multiplexer is MUX. It's usually labeled, no? These are the short labels, no? In a circuit, when you say something MUX, it's a multiplexer. Meron pala siyang meron na pala siyang encoder, and meron na pala siya. Meron nga siyang 2 to 1 MUX. Okay, meron din siyang decoder. Hindi follow? Okay, meron na pala siyang 2 to 1 MUX. So 2 to 1 lang, pero hindi 2 to 4. 4 by 1. O meron, it's the same thing. Let's try to do this, no? Pareho lang ito, no? Do you follow? Pareho lang ito. Meron siyang 4 by 1 MUX. Okay? Inside this 4 by 1 MUX is this whole circuit. So this allows you, like the others, no? Itong other, full adder, meron na siyang 4 by 1 MUX. This is a 4 by 1 MUX also, which means you have 4 inputs and 1 output. Okay? So meron na pala siyang 4 by 1 MUX. I didn't see that. So anyway, wala siyang DeMux. Decoder lang. But a DeMux is actually an encoder. Right? Let's look at our encoder before. Decoder pala. A DeMux is also a decoder. Remember, this is our DeMux, right? Look at our decoder. Oh, decoder, it's the same thing. Okay, actually, it's the same thing. Do you follow? A DeMux is actually also a decoder. Okay, we'll find out why, no? Okay. So that's why you have DeMux and decoder. Kasi pwede rin pala ito. Now this is a 4 by 1 MUX. We have a decoder. 8 by 1 MUX. 3 by 8 decoder. 3 by 8. Do we have a 3 by 4? Kasi what we have is a 3 by 4. 2 by 4. Meron siyang 2 by 4. 16 by 8, 1 MUX. 14 by 16 decoder. Okay, that's why there's no demux, because actually a demultiplexer is also a decoder. If you'll find out, no? Okay, let's configure it out. Let's write it out like it's a decoder. No? Ganito ang pagkasulat natin, no? This is S1. This is S0. So that will be able to determine as a decoder. And our source is D. 1240 pa tayo, no? So ganito ang pagkasulat dito sa ano, but I'm trying to show it this way so that you will find out that it's a decoder also. You follow? And we will have 4 outputs. Y0. Y1. Okay. So we'll need input. We'll need output. Spread it farther. Okay. Do you follow? And then we will need a connectors. Ang problema, ang dami nating connectors dito, no? Okay. 1, 2, 3, 4. We'll need just 4 in ano. Kasi 2 lang naman ito eh. Hindi nating D. Do we need to connect the D? Pababa kasi yung ating ano, no, pagka-drawing. Anyway, we'll just connect it here, no? Okay. The first is a NOT. A NOT of a mahirap eh. No? Isn't it hard like this? Mahirap eh, no? We need how many connectors to D? 4. And we need, mahirap ito gawin eh, no? Like this. So let's not do it this way. Let's do it the traditional way. Mahirap siya i-connect. You lose all your ano. Eventually you will lose all your connectors. We need to connect D 4 times, so we need to have this. Anyway, we're running out of time now. Can we continue with this next meeting?
Yes, sir.
No. Can you figure this out yourself? No. Construct this in ano? In Cedar Logic. I'll construct this myself now and show it to you next meeting. Okay. So what's the difference between a MOOCs and a DMOOCs? A MOOCs chooses the input. A DMOOCs chooses the output. But they are selectors, no? They're called selectors. A MOOCs selects the input. A DMOOC selects the output. And a DMOOCs is also a decoder actually, no? Do you follow? We'll find out why later. Any questions? So see you next meeting now. Thanks for coming. I'll upload this. I think the recording is still intact, no? Thank you very much, everyone. See you next time now.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you,
Sir.
sir.
Sir.